At about 12:20 on the 24th September 1952, the undersea volcano Myojin-sho destroyed the Japanese research ship sent to study it. All 31 people aboard vanished, but debris, a tide gauge record, and acoustic data revealed violent destruction and helped reconstruct the approximate event time. This is the loss of Kaiyo Maru No. 5. 8 days earlier, the sea south of the Izu Islands had begun building something new. Repeated explosions broke the surface, and volcanic material gathered into a temporary island where open water had been. The eruption had started on the 16th September. The next day, the fishing vessel number 11 Myojin-Maru reportedly saw both the activity and the island rising above the sea. Myojin-sho lies in the Pacific south of Japan's Izu Islands, near 31 degrees 55 minutes north and 140 degrees east. It is the summit of a submarine volcanic system hidden mostly beneath the water. Its shallow summit made the eruption especially dangerous. Seawater could meet rising magma close to the surface, turning heat, gas, and water into rapid phreatomagmatic explosions. Japan needed direct observations. How large was the new island? Where was the active vent? And how quickly was the dangerous patch of ocean changing? A government survey vessel received the assignment. Kaiyo Maru No. 5 left Tokyo at 10:15 on the 23rd of September. Its expected route would eventually take it to Shimoda, but first it would enter the waters around the active volcano. 31 people sailed aboard, 22 crew members and 9 survey scientists. They were not chasing a legend. They were carrying out a technical mission in a place already known to be erupting. Reports sent during the voyage described ordinary conditions. Nothing in the surviving communications announced an emergency, serious damage, or a retreat from the mission. At about 20:30 on the 23rd of September, the ship made its last recorded communication. After that message, the record falls silent. Morning brought no warning from the ship. Myojin-sho, however, remained in an episodic eruptive crisis on the 24th of September, even if its surface could appear temporarily quiet. The critical event came on the 24th of September. No eyewitness survived to describe it, and the ship did not transmit a final position or distress call. Kaiyo Maru No. 5 then failed to reach Shimoda. Repeated calls produced no answer. A vessel carrying 31 people had disappeared inside a known volcanic crisis. Searchers had no final message to follow. They had an active volcano, uncertain historical positions, and a broad stretch of open ocean. Currents may also have dispersed floating evidence. At first, the sea offered nothing that explained the silence. Then scattered objects began to appear, each one carrying part of the ship's identity. The search recovered identifiable material in the following days. It included a survey buoy, cabin wood, a lifebuoy, and other fragments linked to Kaiyo Maru No. 5. The lifebuoy reportedly carried the vessel's painted identification. The debris meant the ship had not simply become lost or drifted beyond radio range. Something had broken it apart. Some historical summaries report 22 recovered pieces, including wood, with volcanic rocks embedded in it. The sea had returned evidence of a violent impact, but not the vessel itself. Later accounts describe tests, estimating how quickly volcanic rock would need to travel to penetrate wood. Those exact speed estimates remain less secure because the complete original report was unavailable for modern checking. What the debris established was narrower and stronger. The ship suffered sudden physical destruction in the same waters where a shallow submarine volcano was producing violent explosions. One recovered buoy survived the disaster. It may have separated during the destruction and then drifted under the influence of swell and current, but its exact path is unknown. Yet the search sources reviewed record no recovered hull and no human remains. Without those, investigators could not inspect the ship's structure or reconstruct the final movements of anyone aboard. If no one saw the final explosion, how could investigators tell when it happened? The answer came from instruments far beyond the missing ship. At about 12:53 on the 24th of September, a tide gauge at Hachijojima registered a wave roughly 0.9 to 0.92 meters high. It had arrived from the direction of Myojin-sho. By calculating the wave's travel time, researchers placed the source event near Myojin-sho around 12:20 to 12:25. The reading did not show the ship sinking, but it fixed the eruption in time. A second record had crossed the ocean underwater. SOFAR stations detected low-frequency sound from a major explosive event, carrying through a deep layer where sound could travel enormous distances. RS Dietz and MJ Sheehy compared those acoustic signals with the Hachijo tide record. Their 1953 analysis independently placed the destructive eruption at approximately 12:20 Japan Standard Time. About 12:20 is therefore a reconstruction, not a final timestamp radioed by Kaiyo Maru. Its strength comes from two physical records that pointed back to the same event. Now, the search had a time, a volcano, and identifiable wreckage. It still lacked the one thing needed to prove exactly how the ship failed: the ship itself. The Maritime Safety Agency formed a multidisciplinary committee in October 1952. Specialists examined navigation, communications, geophysics, hull damage, and the volcanic forces that might have acted on the vessel. Their reconstruction placed the vessel beside a force rising from beneath its starboard side. The reported conclusion said the oblique strike destroyed the upper structure, causing the vessel to capsize and sink immediately. A later Sea and Safety article, published in 2025, says it consulted the original investigation report. It preserves the committee's conclusion, though the complete 112-page report was not available for direct inspection here. The committee's reported finding was direct and catastrophic. The vessel capsized and sank immediately. That rules against a long, post-impact drift, but it does not establish whether an evacuation was attempted or why no distress message was sent. But a committee could only reconstruct forces from debris and remote measurements. No witness had seen the angle of impact, and no hull could confirm the damage pattern. An oblique volcanic force from beneath the starboard side destroyed the upper structure and caused immediate capsizing and sinking. This mechanism could explain the silence. Immediate capsizing might have cut electrical power, blocked radio access, or overwhelmed the crew, but the reason no distress message was received remains unknown. It may also fit the limited debris, but only as a possibility. Rapid failure could have scattered light material while the hull was lost. Yet the evidence does not establish its sinking path, resting environment, or why only certain fragments returned. The surviving timeline is brutally short. Eruption begins on the 16th September. Fishermen report the island on the 17th. Kaiyo Maru sails on the 23rd. And the destructive event follows on the 24th. Later volcanology showed how extreme that crisis was. A 1998 study by Fisk, Cashman, Shibata, and Watanabe described an unusually violent shallow submarine eruption with hundreds of phreatomagmatic explosions. When magma meets shallow seawater, expansion can fragment both magma and surrounding rock. The eruption may launch blocks, drive pressure waves, and displace water faster than a nearby vessel can escape. The blast was not the only danger. Hot, fragmented material, a water-rich surge, or a dense gravity flow could race outward from the vent and strike a ship beyond the eruption column. This creates the central limit of the case. The volcanic cause is strongly supported, but the exact killing mechanism remains uncertain. The official explanation favors an oblique force beneath the starboard side. Later, science allows a blast, surge, ejector, water displacement, or several of them arriving almost together. Could the fatal eruption have come from somewhere other than Myojin-sho's main cone? In 1955, Yushiro Tsukamoto proposed a separate high called Takane Sho as an alternative source. The proposal tried to reconcile conflicting positions, rock characteristics, and questions about the reported damage. It remains a legitimate historical hypothesis, not a demonstrated solution. Japan Coast Guard surveys later mapped the underwater terrain more clearly. A 1989 Manbu survey identified the steep Myojin-sho cone and a separate central high associated with Takane Sho. The mapping confirmed that the two features were distinct. It did not show that Takane Sho produced the 1952 explosion, and later discussion has questioned whether its depth fits such a large event. The ship's exact final position is also uncertain. Modern JMA coordinates mark the volcano, not Kaiyo Maru's location, and conflicting older positions cannot be repaired with a GPS record that never existed. Compass error, geomagnetic disturbance, and echo sounder problems have all been discussed. None is demonstrated by a surviving instrument log, so none can safely explain why the ship was where it was. That uncertainty later invited stories about a naval collision, a Soviet submarine, or supernatural waters. The physical record supports none of them. Those stories replace missing details with causes for which no evidence was found. The documented threat never vanished. Modern Japan Coast Guard aircraft and survey vessels still approach Myojin-sho to inspect the sea, measure its shape, and watch for heat, discoloration, or renewed eruption. The volcano's current reference point is near 31 degrees, 55.1 minutes north, and 140 degrees, 0.3 minutes east. Its shallowest point is about 50 meters below the surface. On the 16th April 2026, official observations found no satellite-detected eruption, discolored water, or other special phenomenon. Quiet water, however, did not cancel the danger beneath it. JMA kept the surrounding sea warning active because another undersea eruption could not be ruled out. The charted safety treatment has changed since 1952, but the volcano remains monitored. Kaiyo Maru No. 5 did not vanish without evidence. A recorded wave, underwater sound, volcanic debris, and the investigation all point to destruction during the Myojin-sho eruption. What remains unknown is narrower: the vessel's exact position, the precise vent, and which volcanic force struck first. No paranormal answer is required, only evidence the sea never returned. A volcano destroyed the ship sent to understand it, and 31 people were lost before anyone could hear a warning. Which force do you think struck Kaiyo Maru No. 5 first?